All right, here we go. Go to make an x and y axis. Make an x and y axis like, say, as big as mine right here. Okay. Just about like maybe like a on the top left corner. Make an x and y axis like this. 10. 10 units to the right, up, down, left, and down. And then next to that, go ahead and make an input-output table. Let's make an input-output table. But we're going to make 3 of them. They don't have to be big. Just make one input-output table, another one underneath it. Just make it like this big. Look at your x and y axis like as big as mine right there. Nah, quarter. And then make 3 input-output tables on the right side. It's a little table, just 3 of them. Okay, everybody with me, I trust. Make 3 of them. So look, I got 3 input-output tables on the right side. All right, thank you. Let's call this one function 1. Function 1. Function 2. Function 3. Watch and see. So for the first input table, let's plot -1, +4, -2, +3, and -3, +2. So write those in the table and go ahead and plot those puppies. Right, Rodriguez? Let's plot these puppies. So -1, 4. We got -2, 3. And we got -3, 2. And let's just connect the dots for now. I'm going to show you something. Just connect the dots. There's our first function. It's got a limited domain, obviously, because the arrows don't go top to bottom. It's got a limited range. Okay, that's function 1. All right. All right, for function 2, right here, we're going to multiply. Go and write multiply every input by -1. Yes. So go ahead and try. So multiply every input by -1 from function 1 and put the new inputs here. So every input here multiplied by -1, that'll be your new input, and keep the same outputs. Is Gomez right? Say that one more time. You're absolutely right. So every sign will change. So if I multiply everything by -1, So Castro, give me the inputs then. Go for it. Beautiful. Go and do that for me. Now plot those puppies. So 1, 4, 2, 3, 3, 2. Okay. From function 1 to function 2, what the heck took place? How can I summarize this transformation? Reflection around what? Y-axis or x-axis? The y-axis. Here's your y-axis. Here's your line of reflection. We took this function, thank you, gentlemen, thank you, and I flipped that puppy over the y-axis. So what can we summarize here? If we multiply the inputs by a negative number around, so put reflection on the y-axis for function 2. We multiplied every input of the original function by -1, so it's a reflection on the y-axis. There he is. Color code this puppy. What do you suppose we're going to do now, class? And what do you suppose we're going to do to the function 1 to reflect it in the x-axis? By a positive 1? If we multiply something by positive 1, nothing will change. Think about it. I mean, maybe I'm wrong. By. So here, function 3 will multiply the outputs by -1, and we'll get a reflection in the x-axis. Let's verify that, though. All right, so let's look at function 1. Every output, multiply those puppies by -1, so we'll have a what? Thank you, Ms. Castro. I'm going to go in red here. Very good. -4, -3, -2. Inputs will stay the same. So function 1, we're comparing, so the inputs will stay the same. All we've done is taken the outputs and multiply by -1. So -1, -2, -3. So what do we do? On your notes, let's verify. We multiplied outputs by -1. What's that going to do? We're about to find out right now. Let's do it. Let's see. -4, let's see, -1, -4, -1, -4, -2, -3, and -3, -2. There you go. Reflection now in the x-axis. I took the original function 1 in black, and I flipped it over the x-axis by multiplying the outputs by -1. So let's summarize there. Reflection on x-axis. Yikes. Got you. So you turn the page over and you see this, reflections in the x-axis, reflections in the y-axis. Basically, this is summarizing everything we just talked about. And let's get into an example now. Give me g of x now. So we're on the second side. It's going to be okay. So here's f of x. Write a function g of x, in other words, a new function, that takes this function and reflects it in the x-axis. Okay. Now, before we get to that, before we do this one, let's look at the top. I forgot to review the top with you guys. Forgive me. All right, so reflections in the x-axis. On that graph paper I just passed out, what do we multiply, the inputs or outputs, to reflect it in the x-axis? Output. So look at what it says. The graph of y equals negative f of x. Look at the whole function is negative. Because the outputs would be the function itself. The inputs would just be x. The output is what you do with x. You have to multiply it by something, add something, so it's a whole function. So it's, yeah, this means the output. So the opposite of the output. In other words, -1 times every output is a reflection in the x-axis. Look at multiplying the outputs by -1 changes their sign, and we just did that together. Versus reflection in the x-axis, look what they're doing here. They're just taking the input x and multiply it by -1. So here, look at the difference between here and here. The negative is in front of the whole output, f of x. The negative here is just in front of the input, x. So this is the y-axis reflection. This is the x-axis reflection. What we just did on our graph paper. So when you see f of x, you're thinking output. When you think x, you're just thinking input. So, example 3, let's do it. Let's do this. So you got this written down in the little note section. Write a function g that does this, reflection in the x-axis. Here we go. Okay, so it's a reflection in the x-axis. Do I multiply the input or the output by -1? Let's see, let's go back up. Right, look at the whole output. X-axis, I have to multiply the whole output by -1. Okay, here, in this function, the output is actually this. Look at the output will be all of this. All of this is your output. Because if you give me an input and put it for x, I have to multiply by 1/2 and add 8, then I get the output. So the output is the whole function itself. The whole equation part, the whole expression is your output. Your input is just that, the x. So I have to multiply the whole dang output by -1 to get my new function. Watch this. Are you sure? Watch this. -1 times, watch this, the whole dang output. 1/2 x plus 8. That's your output. Well, let's distribute now. It's bad manners to leave an expression undistributed, right? Question? Nice. Let's distribute -1 here. Here, let's see what happens. G of x equals, careful. Right, -1 times 1/2 is -1/2. X. -1 plus negative plus positive is -8. Here's your new function. What? No, this is a plus negative, which means the same thing as minus. Let's go to Gomez and then Vega. Go ahead. Well, mission accomplished now. We wrote a function g. There it is. We took that function, f of x, and we reflected it over the x-axis. Here's your new function. In other words, if I were to type this in my Desmos calculator, this would be a reflection over the x-axis of that one. I can verify it later, but I'm pretty confident you guys believe me. Question? That's just what I prefer. But to answer your question, well, I did answer it. It would be an equivalent expression, we call it in math. In other words, you could write it this way. That's why I do it. I just want to bug you. Just kidding. Watch. Look at. This and this mean the same thing. In our minds, as Math 3 students and more advanced mathematicians, we need to understand that this means that and that means that. Stop fake claps. Stop that. That bugs me. Yes. Right, in one sense, yeah. If you can do the distributive property in your mind, knock yourself out. Yeah, I'm just going step by step for us right now. If it was a 2 or 3, then we're talking about stretches. If it was a -2, we're talking about a reflection and a stretch at that point. Remember when the coefficient's bigger than 1, we're stretching. If it's smaller than 1, a fraction, we're shrinking. You see that? But let's say it's a -2. It would not only be the reflection because it's negative, but it would be stretching also. Two things at one time. Good question. Yes, Flores. If it's a -2. Anytime you got a negative, that's the reflection of some sort, either over the y or over the x. You see that? Okay. If it's positive, it's just a stretch or a shrink. Look at this number, the number itself. And we're going to get into that more too tomorrow. One more example. You with me? Let's do it. This was example 3, last example, example 4. You guys are doing good today. I'm very proud of you guys, I must say. Let's do a reflection on the y-axis. So number 4. Let me find an example here. All right, example 4. Let's do this one. So same mission. Okay, same mission. But we're just going to reflect this absolute value function in the y-axis. Let me get this here, makes it a little smaller here. Okay, so I'm going to write this one down. So write a new function g. That does this, reflection in the y-axis. That AC will kick on shortly, guys. Bear with me, I know it's a little stuffy in here. Forgive me. Forgive me. One more time? I don't know what's going on. It's one of those economy ones where it turns off to save energy and stuff. Anyway, all right. So we want to take this function and reflect it over the y-axis, not the x-axis. So coming to the top, the y-axis, we got to multiply every input now by -1. In other words, just the x, not the whole function, just the x, which is kind of easy. Watch, check it out. G of x equals 4 plus -x, so -1 times x, plus 1. We're done. Where are the inputs here? The inputs are right here. X is always your inputs. So all I did is took that input and multiplied by -1, and we're done. Here's g of x. Well, the absolute value, they're not parentheses, so they're just absolute value of -x plus 1. All right. Let me graph both of these really quick so you can see how it reflected over the y-axis, just by doing that one little negative on the input, and we're done. Excuse me? No way. Did Castro actually say that? Give me the first equation. The absolute value on example 4. Was it? Absolute value of x plus 4? Plus 1, you said, huh? All right, look at this. Yikes, that sounded like it hurt. All right, check it out, you guys. Look what we just did. Look what we just did. Merely by taking every input and multiplying by -1, the first function that I threw at you is right here in purple. Let me put it in projector mode. It's hard for you to see here. There we go. All right, look at the first function is in purple, Castro. You're going to love my class even more if you pay attention. Watch this. Here's the absolute value in purple. We took the purple and we reflected it over the y-axis. So the red now is a reflection over the y-axis here. This flipping over here. Just because of the negative inputs. Okay? I'm done. Grab your Chromebook. 2 and 3.